Okay, guys, sorry, light went out, so I had to post the video. So we were talking about static routes, and what that static routes do is that they connect specific network. They connect a specific network, connect a stop network or a stop router. What I mean by stop is a network that has only one entry and exit point. Let's say, for example, let's take an example diagram here. I think I'm gonna have to do some drawing. Now, for instance. Uh, let's say this is my router and I have another router here, but this my router. Now let's connect these two routers. Okay, now this my router here is connected to the internet. Okay, now this is my ISP. Okay, that's my ISP right there. Okay, alright, this is my ISP. So behind my ISP here, any other network that I might have here would not be visible to the router here, because this is my customer router. So I can call it my CPE, for instance. That is a customer premises equipment. Alright, that is my CPE and that's ISP. Now ISP would not give me the LANs that they have here for other networks or other networks other customers network. They cannot give me, because with dynamic routing protocol it requires that this ISP and this customer premises equipment to have dialogue amongst themselves. So you have to avoid that by either configuring BGP or you configure static route. Now with normal static routes, this is what you're gonna do. Okay, you're gonna have to set the CPE router here to reach these networks behind ISP. But if it is a stop network, so this ISP is a stop network because all the networks behind this ISP cannot be known to your CPE router. So this is your customer premises equipment router. So in that case, your customer premises equipment will have to route a traffic that is unknown. Okay, you just have to route a traffic that is unknown to the ISP, but the ISP knows those networks that the CPE is unable to catch behind its other side. So therefore the CPE relies on the default static route that says from any network to any network, just route the traffic to your next neighbor. So that's what exactly the default static route is all about. Okay, so I hope you guys picked that point. And summarize static routing. I forgot about this whatever because we have about 4 static routes. I just mentioned about 3, so I think it will be fair if I talk about all the 4. So there's another one here. Like I said, we have another static route called the summary static route. So I'm gonna have to do some summarization here quickly. Summary static route. With a summary static route, you do not want to let's say for instance I want to send one route. Okay, I want to summarize this network and that network into one single network so that I can forward the packet immediately. So let's say for instance I'm going to summarize this 10 network here and I'm going to summarize it. So for instance, if I'm doing a static route, okay, let me just take my arrow. If I'm to do a static route to reach this network, I need to also set another static route from this router 1 to reach this other network. So there are 2 statements. So what if I have multiple routes here? Maybe I have another LAN here, I have another LAN here, maybe I have 50 LANs all behind router 2 here. So do I need to send a single route statement for each of those network individual LANs? What I can do is that I have to just take those IP networks together and then I summarize them into one subnet. So I have to summarize these 2 networks. So how do you summarize? I'm gonna do this for you guys. Okay, add a page. Now that is one thing. Before we go into any other thing, let's increase this thing to something bigger so we can see what we're doing. So yes guys, I need to drop that and then maybe take this again. Alright, so let's say for instance those are the networks. We have 10.1.1.0/24 and 10.1.2 1.2.0. all of these 2 networks that are behind router 2, I need to summarize them. I need to bring them down. So what I need to do is I need to put the 10 in binary. Okay, that 10 right there, this 10 in binary, the 1 in binary, this other one. So I'm gonna have to reduce this thing a little bit. maybe to something like 22, something that is visible. Alright, so the 10 in binary is 0000 1010. Okay, the 1 in binary is 000000 and 01, so that is 8, I think. Yeah. Okay, so the other one also is 1 2 3 4 5 6 7 1. The 0 in binary is 1 2 3 4 5 6 7 8. So that is what you have to summarize. Next one, the other 10 also is 1 2 3 4 1 0 1 0 dot. The other one also 1 2 3 4 5 6 7 8. The other 0 is 1 2 3 4 5 6 7 8. And sorry, this is 2, so we're gonna have 1.0, sorry, 10 dot let's say 0 and 0. So this is what you're gonna do. So now there's one thing we're gonna do. We're gonna have to AND this. So let me just draw a line underneath this whole thing so we know exactly what we're doing. So we have to AND this. Okay, so ANDing here, before you even AND, this is what you're gonna do. Okay, so let's AND and see what we have. Okay, let me take this back. So if I have this 0 and this 0 in the ANDing, I have a 0, right? Right, that's one thing. So 0 and 0 is 0, 0 and 0 0 0 0, and 1 and 1 is 1, 0 and 0 is, and 1 and 1 is 1. So that one is 10 is 10. This other side, everything remains the same because everything there is 1, and here everything here is all 0, and here is 1 and a 0. You can see that these ones, they're all disqualified, those two. Okay, this is 0 1 and this is 1 0, so therefore everything becomes a 0. That here everything is 0, so you have to AND this. Now after ANDing, okay, I have AND these two networks together. Now my network, when I AND this, the end result, okay, the end result is 10.1.0.0. What would be my CIDR now? That's the most important part of this whole thing. So now if I do this, what is my CIDR? Okay, my CIDR would be, because this is my answer. Okay, so let me just roll over this whole this damn thing. Okay, let me bring it down here because I AND this. So the answer gives me this. So you guys need to know how to summarize networks. So now after I summarize, I put it back down and I just checked it. Everything is fine. Now the thing is that I am going to count my host bits until I reach my last merchant bit. So now I'm going to do this. I'm going to check this drawing board again. Now look at this. Everything here matches. Okay, you can see everything matches all over here. Everything matches. But if you come all the way here, the match stops here. The matching ends here. That's where you have to match and end. That's where the two margins end. So you can see it ends right here. So what you will do is you're going to count the bits from here, okay, all the way until the margin, and that will be your CIDR. Okay, now this is what you have to count. So basically I have 8 here, that is 16 plus this is 22. So my CIDR in this respect is CIDR 22. So if I have to summarize this network, I'm going to be using CIDR 22 as my CIDR, because whenever you summarize, your CIDR would drop down. Okay, whenever you summarize, you will not have an as well, but your CIDR drops down. So that's how to summarize. So that is one network. There is another network that we need to also summarize. So let's look at the diagram. Okay, there is 192.168.10 and .11 here, so we have to summarize those ones. Okay, so let's add another page. Alright, so let me just do this.